Okay, I want to talk about spot rates today. When we value bonds, you have done this in the past. You say, all right, well, this bond has, 4 years maturity. It pays semi-annually, so 4 times 2 means it makes 8 payments. It has a coupon rate of, let's say 7%, and a par value of $1,000. So future value would be $1,000. 7% coupon would be 70. Pays twice a year divided by 2. That's equal to 35. So we can draw a timeline. And remember, the way to think about this, by the way, this right here is the payout rule. Remember, this is set by the issuer. This is set by Coca-Cola or whatever company it may be. And the way we think of this is not a bond. This is a money machine. This is a money machine that has promised payments. And we can draw a timeline and look and see what those payments are going to look like. And we say, here's today, here's period 1, 2, 3. I'll skip all the way up to period 8. It's going to pay $35, $35, $35 every 6 months until maturity, and it pays $1,000. So we know if we put these numbers into our calculator, we know the value of any financial asset, or the value of the bonds, the present value of the future cash flows. So we know the price is equal to 35 over something. 35 over something. Keep going out to 1,035. But what do we put this over? We have 1 plus, I'm going to put lowercase y to the first, 1 plus lowercase y to the second, and all the way up to 1 plus the lowercase y to the 8th. So if you tell me, in the financial calculator button is IY, if you tell me the yield to maturity and divide that by 2, then that's going to give me the yield that this bond's going to get. So let's say the yield to maturity is 8%. We divide by 2, we have 4%. That gives us the price of the bond. Here's the thing I want you to notice. We have said the yield to maturity is the same number for every time period. So this y is the same for all of them. And I'm going to say that's not really correct. The real way to do it is this. The price today, and by the way, I should have a little P0 there for price today. The price today is 35 divided by, I'm going to call this 1 plus Z1, and 35 divided by 1 plus Z2 squared plus 35 over 1 plus Z3 cubed plus all the way up to when this ends, 1,035 divided by 1 plus Z4 to the 4th. So what I would want to do in this particular case is I need to figure out what the true interest rate is. And the way to think about this is 6 months out. This is 1 year. This is 18 months. And this is 8 years. I'm going to have 16 different interest rates that correspond to the 16 different time periods where this bond makes a payment. So I really don't think of this as one bond or one money machine. I think of this as 16 bonds making 16 separate payments at 16 separate times. So how do I know how to price this? Well, I need to have a way to find what these Z1s are. And that's what we're going to do next. But just a little terminology here. I'm going to have the spot rates. That's what these are called, the spot rates. And the spot rates are given by the present value is equal to the future value over 1 plus Zn to the n. So I'm going to do the calculations because almost everything is semi-annual, right? Almost all bonds are semi-annual. So I'm going to do all the calculations in semi-annual terms. But when I actually report the spot rate, so rather than saying the 6-month spot rate, so the 6-month spot is, I don't say Z1, I multiply that by 2, and I call that R1. So all the rates I refer to when I say what the rate is, I'm talking about the R's, where R2 is equal to Z2 times 2, R whatever, is equal to Z whatever times 2. So this is what I'm going to report to you, but I do all the calculations with the Z's. Okay, so let me pause that for a second and get some Excel material. Okay, so here's some data from an Excel printout, and what I've done, I look at the observed market data. So here's the observed market data right there, and I have a problem, and my problem is I need to find the price of a 2-year semi-annual pay $1,000 par 5% coupon bond. So I know the problem is going to look like this. So drawing the timeline to me is extremely important. 0, 1, 2, 3, 4, and this is going to pay 25, 25, 25, 1,025. So the price is equal to 25 over 1 plus Z1 plus 25 over 1 plus Z2 squared plus 25 over 1 plus Z3 cubed plus 1,025 over 1 plus Z4 to the 4th. I don't know the Z's, so how do I find the Z's? Well, I'll look in the market and see what's going on in the market, and I know this. So I know that I can buy a 6-month, I know I can buy a 6-month T-bill for a price of $98, and it's going to pay me $100 at the end. I'm doing this in percent of par, by the way. I could call this 980 and 1,000. I could call it 9,800 and 10,000. To do in percent of par, this price is 98% of par. So it's going to pay me 100% of par, and there's no coupon, so it pays nothing else. I'll put the plus 0 there, but you don't really need it, over 1 plus Z1. So when I do the math here and I solve for Z1, Z1 is equal to 0.02041, which is this number right there. Alright, so now I continue the process. And I go to right here and I say, okay, I find another T-bill that matures in 1 year, and it pays me, I'm going to go ahead and put this, it's going to pay me $0 in 6 months over 1 plus Z1, plus it's going to pay me 100% of par plus 0 coupon, and the value of that is 1 plus Z2 squared. So see, the value of this bond is what it pays in 6 months, even though it's nothing, plus what it pays in a year. So this of course just goes to 0. I can solve for Z2. Z2 is equal to this right here, which is 0.02598. Okay, so now going to the next one, this is where it starts to be a little bit more work. At 1.5 years, I can no longer observe a T-bill because no T-bill exists. There's strips. Well, we can talk about why strips may not be the best thing to use. So for 101% of par, I get a bond that pays 6.25%. So 6.25 divided by 2 is equal to 3.125. So it's going to pay 3.125 divided by 1 plus Z1. Well, Z1 is 0.2041 to the first, plus 3.125 over 1 plus Z2, which is 1.02598 squared, plus 103.125 divided by 1 plus Z3 cubed. And you can see why this is called bootstrapping, because I'm bootstrapping up the spot rates. I'm having to start with Z1 and go to Z2 and go to Z3. By the way, what I can do now, I know that this, I find this Z3 is equal to this number right here, 0.02598 0.02785. So I found Z3, I found Z2, and I found Z1. Now I can plug those in, but I still need to find Z4. Alright, let's see, what color can I use for Z4? Let's go with, I'm starting to run out here. We'll see if this works. Here's Z4. That's going to be 99%. Oops. It's going to be 99% of par. That's not dark enough. 99% of par. It pays 5.75. 5.75 divided by 2. What is that? It's 2.875. So 2.875 divided by 1 plus C1, which is that, 1.02041 to the first, plus 2.875 divided by 1 plus Z2, which is 0.2598 squared, plus 2.875 divided by 1 plus Z3, which I just found, 1.02785 cubed, plus 102.875 over 1 plus Z4 to the fourth. So this is pretty painful algebra, right? But we can still do it. So there's Z4. So now I've found the price, and I found the spot rates, and now I can find the price from those spot rates. I'm starting to run out of room here. Let me put this back up. So I know the price is going to be equal to 25 over 1.0241 plus 25 over 1. I'm getting them from right here. 0.2598 squared plus 25 over 1.02785 cubed. I know this is enough busy work to like should I really even major or get a concentration in finance, but it's not too painful. So doing all this, I find the price. This price is equal to 976.00. There's my price right there. So now I need to find the yield to maturity. So I know N is equal to 4 because it makes 4 payments. Payment is equal to 25. Future value is equal to 1,000. The price or the present value is minus 976. Plug this into your financial calculator. Press the IY button. Whatever you get here, call that Y. The yield to maturity is 2 times Y, which in this case is 6.296%. So here's the takeaway. The way we come up with the yield to maturity is it's not given to us. We do these steps. First we find the spot rates. Given the spot rates, we price the bond. Given the price of the bond and the payout rule, we find the yield to maturity. So that's how it happens. Hopefully you remember that from what we've already done. But given that, now the next thing to think about is where those spot rates actually come from, why they are what they are. So those are the mechanics of finding the spot rates, finding the price, and finding the yield to maturity of a bond.